Everybody wants this one.
Okay. Good afternoon.
Good afternoon. Hello.
Thank you. Hello. And then I think one more session. I think it's good to work here because I haven't talked about division yet.
Wrote the books as well.
Yeah, you can. I already wrote what to do in the book, but
Yes.
I think it's good to solve some exercises for division. This is also something you have already learned how to divide fractions, but it doesn't hurt if I actually review it and complete it. But before that, let me, I don't know, let me ask you one question. If I want to see how much you remember from what I told you before. Let me, yeah, or let me give a new problem. So this problem is a little bit hard, but I want to teach you something. This is not necessary for this course, but the people who are interested to learn more, it doesn't hurt to know these things, because from mathematics knowledge point of view, it is at the level of your mathematics. But I told you that problems, because sometimes the students think that lengthy problems are hard problems, but in mathematics, the problems that you have to be very smart or creative are hard problems, not the problems that you know what to do. Even if they are one pages, you know algorithmically what to do. I don't consider them hard problems. But let me write one problem here, and then when you think about it a little bit, I will teach you this trick, and then I will give you another one to see how much you can use that one. Then I go to the next part of the lesson, which is division. And then we end up this. Next time, I will give you time to practice a little bit. On Fridays, definitely, I will give you time to practice. About Thursday, I am not decided yet. Let us see how it goes, okay? But then I will go to the next topic, which is also very important, exponents and powers, okay? So here, this I want you to calculate this. So I would write 1. And of course, even if you calculate it using Geogebra, that's not bad, you know. 1 over 1 times 2. Okay, it's a little bit of a strange way of writing things, but just be patient. Over plus 1 over. This time I take 2 times 3. And then I will take plus 1 over 3 times 4. And then, as usual, dot 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 means that I follow the pattern. And then I will end up here, 1 over 99 times 100. Okay, so of course, this is 1 over 2, this is 1 over 6, this is 1 over 12, and the last one is up to 1 over 9,900. Of course, the reason that I have written it in this way, because I am just giving you a hint a little bit how to do it, and this is also common. So what I want you to do, first of all, try to think how can you find a smart way to simplify this without calculator. And then of course, even if you can put this in the Geogebra, that's also valuable to me, because then you need to understand how to put this in Geogebra based on what I told you before, okay? So I will give you a little bit of time so that you can try to, by the way, there is no way that I can teach you how to solve hard problems. We can discuss together, but everyone will take as much as they know or based on their background and things like that. If I could teach you how to solve hard problems, I would have taught myself in the first place to solve all hard problems. This shows that this is not possible, okay? Okay, this problem, I don't know, the person who actually designed the question first or how it comes, I don't know, but it might be that person was a genius thinking about these kind of stuff. Of course, designing, if you have an idea, you can design a problem, but reverse engineering the problem might be harder for the person who is going to solve the problem later. But I can give you a hint. By the way, this is very common. In the books that they have hard problems, you can see two kinds of faucets at the end solution. One is not just the solution. One is a hint to a solution. So it means that if you cannot solve, don't jump to the solution. Go to the hint. There was a very short hint. Try to read that hint, and then again try to think, can you do it or not? This is up to you. This is some kind of life activity. If you like it, this is the way that you have to learn it. Okay? So you have to have a goal. If your goal is to be very successful in mathematics or related careers, the careers related to mathematics, this is the way that you have to do it. So you have to be stubborn. Probably 1 or 2% is just talent. The next thing is hard work and how dedicated you are. Okay, so let me just give you a hint. Okay, I want to do some strange things. You might say why you are doing this, but you will learn later. Okay. First of all, I would write 1 over 1 times 2. By the way, if I ask you what this guy is, you just say it's 1/2. Yes? It's written in this strange way. I want you to write this like this. First of all, do you agree with what I am writing or not?
Yes.
Are these two equal? Because if I ask you what is the number on the left, your answer is 1/2. And now don't look here. If I ask you what this number is, you would say it's 1 minus 1/2 again 1/2. And 1/2 is equal to 1/2. It's completely true. Okay. Do you need more hint or not? Let me write one more. I will take this one. This is engineered in a very nice way so that this becomes what? It's 1 over 6 on the one hand. On the other hand,
1 over 2 minus 1 over 3.
do you agree? Let us check. If you don't believe, you go to a scratch work. You calculate this one. Everyone should. This is at the level of the book. 1 over 2 minus 1 over 3. What is the common denominator? 6. This to this 3 times. This to this 2 times. And if you calculate, it becomes what? 1 over 6. So what I have written here is valid. On the right hand side, it is 1 over 6. On the left hand side, that's also 1 over 6. Okay? And now, if you train your brain to catch the patterns, probably you will understand what to do. Okay? So I just wait a little bit more. Okay? To see, finally, is there anyone to come up with a solution for me or not? Okay? So I will wait a little bit more. The first thing that if you are an observant student, the first thing you need to ask yourself, okay, is it a coincidence that the first two works or this pattern will always work? For example, do you think that is also true? How many of you actually checked this one? This is important because they have written something in front of us. We check these two individually, but there is no guarantee for the next one it works. So at least you have to convince yourself somehow that this pattern is going to continue, yes? But this one is also true or not?
Yes.
It is true, yes? Why? Because in your head you can multiply them to take the common denominator, 12, and 4 goes here, 3 goes there, yes? So do you understand how I'm doing? 1 over 3 minus 1 over 4. I always told you that don't multiply them, but there are some exceptions. Here, if I multiply them, I would say this to this 4 times, minus this to this 3 times. And then 4 minus 3 is 1. Yes? So because I am going to ask you the same question for the last one. Do you think I can continue? Let me just write here. Intentionally, I write very low here. So this 100. Okay? Still, now the numbers are big. You have to convince yourself, first of all, this is true. It was more or less obvious that these are true because the numbers are so small that we could calculate it immediately. But there is no guarantee, by the way, this is mathematics, these things that you need to learn. There is no guarantee that if it works for 3 cases, it will also work for the next case, unless you have a good reason for that. Now my question is that, are you really buying this argument from me that this is also true because I just started to show you this and then jump to this conclusion? So I mean that you need to ask me why this is true, okay? So for example, can you convince me the last one is also true? So 1 over 99 minus 1 over 100. If I ask you what is the common denominator between 100 and 99, what is your answer? 9900. 9900. Yes, how did you find that? So you multiply them here. Okay? And then you divide this in your head by this. How many times? 100 times. 100 will be multiplied here. And then this one 99 times. Is that understandable what I'm doing? Yes? Okay, and then 100 minus 99 is again 1. So that's correct. Okay? Now let us look at the beauty of the problem. So why do you think this is useful? Of course, we discovered a nice pattern. On its own, this is a nice pattern. But why this is useful for this problem? Because we are going to solve the problem. I want to ask your intuition. Can you tell me what is the previous term that I haven't written? It is included in these
98.
dots.
98, 97.
Now, first of all, tell me. It's a fraction. The numerator is 1 and the denominator is
98.
98 multiplied 99. The previous one is
97.
97, 98. So it means that this pattern will continue. For example, for the last one, which is 98, 99, you can immediately convince yourself that you can also do the same thing. Do you agree? Yes? Okay, I think more or less it is enough. And I think it's a matter of an educated guess from your side. Why this is useful? Everything that I have written, hopefully I was able to convince you, every one of these statements that I have written is true. But why this is useful for the case of this problem?
Because then you can use the other formulas you learned.
No, we don't have any formulas for fractions.
But that's for whole numbers.
Whole numbers.
Okay.
Yeah. Broaden your perspective. It's not hard now. It's crying out how to solve me.
It's like minus plus, so it's 0.
Yes, that's a good idea. Why don't you trust yourself? But you need to elaborate that. Everyone, that was a hint. So my goal is to what? To find what? To find a sum. Let me call this sum S. That sum is not this sum. It is the sum of these numbers. Do you agree?
Yes.
My goal is to be able to add them. But I told you that this number is equal to that number. This number is equal to that number. This number equal to this until this number is equal to this. So do you agree with me? Instead of adding these numbers to get the answer, I can add these numbers to get the answers because they are one by one equal. First of all, agree or not? Okay? But adding these numbers is hard. Adding these numbers is very easy. Why is that? Because as you said, one by one they cancel out. So when I want to start adding them, minus a half, it was engineered in that way. Minus a half appears with a negative sign. In the next term, it appears again, but with the positive sign. So when you start adding them, it is like a telescope. It actually it becomes shorter and shorter. So this one will cancel that one. And this one you see again, appears here with negative sign, here appears with positive sign. So this one is cancelling this one. And then do you think minus 1/4 will also be cancelled somehow? Yes, with the next one. And then if you continue, all these cancelling happen. And then look at the last one. Minus 1 over 99, cancel this one. Do you think this is also cancelled?
Yes.
With which one? With the previous one. Now, adding these things up, then you will have this one, which is what? When you raise your hand, I see, okay? Yeah, just drop it, and I will come back to you. Okay, then if I add them, what happens? Only two terms are left. 1 over 1 minus 1 over 100.
99 by 100.
And then you can calculate this. This doesn't need really a calculator because you can write what? 100 over 100 minus 1 over 100. The answer is
Perfect. Thanks.
So that is a nice problem. So you see, these tricks are sometimes extremely hard to discover. Okay, so the people who are interested in mathematical contests, so they have to improve their ability. By the way, we are also working on it. Last year we actually registered our school, and it was better than I expecting. So the students from the first grade actually try to solve some of those problems. They are extremely hard, so I can also introduce and put the links here. If you are interested in those kinds of problems, then I can help you a little bit to see how we can do. Okay. But one thing that I want you to tell me now is how to put this number in GeoGebra. Because this is also not that simple. I want you to tell me how to do that. Do you remember yesterday we talked about, if I remember the syntax correctly, it was sum. Do you remember what was that? Here, I think it was expression. Here, it was variable. Yes. Here, it was the initial value. Yes. And here, it was the final value. Yes. Something like that. Okay, you tell me what to do, and then I test your idea in GeoGebra to see if you are right. You want to answer? Yes.
Can you do, for the expression, 1 over n squared plus n?
Yes, but yeah, that's completely correct. But why did you say, don't say n squared plus n, that's correct. What should I write?
1 over n times n plus 1.
N plus 1. That's extremely good guess. Yes, because what he is thinking, to look at the pattern, is that all of them are fractions. So in the expression part, I need what? First of all, why I am using this syntax? Because I am facing a sum. And this is a sum. Yes, first of all. Secondly, what is for expression? You see that all of them are fractions. So it means that I need a fraction line. All of them have a 1 in the numerator. So I put a 1 in the numerator. But the denominators are different. But something is clear. These are consecutive numbers. 1 times the next number 2. This is 2 times the next number 3. This is 3 times the next number 4. So the pattern reveals itself. Yes? So it is a number n multiplied by what? The next number. What is the next number? N, whatever it is, 1 more. Okay? So this is the pattern. And what is the name of variable? You decided to choose the name of the variable n. And then the initial value. What is the initial value for n?
1.
1. Because the first fraction starts with 1. And, okay, don't get confused. What is the final value? Can you tell me? What?
99.
99. So this is what we expect to put in GeoGebra to produce the same answer. Okay? So let us see if it works or not. Okay, so we open GeoGebra and we go to CAS view. And by the way, we don't need this graphing things here, so we can get rid of it if I remember how. Yes, we go to view and then take the graphics out. Then we have this. Okay, so we come here and try to type. So sum, I remember it was a capital S, so yes. So we go to this sum and then choose this one. So the expression, as you told me, it's 1 over n times n plus 1. It automatically takes care of that. So, and then the variable is n. Yes, and the starting value is 1, and then you told me the final value is 99. So if I predicted everything correctly, it's 99 over 100. So that's also extremely useful. So you see, now you can, this is something that you will learn later. This is, in mathematics, by the way, they don't write sum. So let me change the camera view, because now I am recording GeoGebra. So webcam, so, okay, let me just do that. In mathematics, this is the way that you use in computer science or coding. In mathematics, sum has a Greek letter notation, sigma.
There it is.
Okay? And then you write 1 over n times n plus 1. And then n is your variable. You put n here. It goes from 1. You put n equals to 1 up to 99. So some softwares and applications have this sigma notation, some of them. But in mathematics, I will not write like this. This is usually in computer coding. I write like this. So this is completely famous. If someone asks you to calculate this value, they mean to calculate this sum. Okay? So that is also something, of course, we learn a little bit about sigma notation later. But actually you did. You learned. You were able to write this as a sigma notation. But instead of writing sigma notation, you use the word sum. Okay. So there is also one problem I see here in this book. It is, I would say it's extremely challenging. I will write it here, but I will not solve it. If you are interested, think about it when you are at home, okay? And whenever you get bored, you need to throw it away and then come back later when you are fresh, okay? And then we will discuss about that. So let me just write this, and I also want you to check it out using GeoGebra, because writing probably this pattern would be a little bit harder.
If someone solves it, you check the answer, or do you not know the answer?
No, you can come and present here. I know, I can calculate the answer. It's not hard. I can calculate it immediately. But you can come to me here and show the answer. And if you want, by the way, this is one skill I want you to learn. Be able to talk in front of others. So if you are comfortable with doing that, you be my guest. If you check some of my videos, I have invited a lot of students. They were confident to come here and solve the problem and being recorded and being on YouTube. Okay? You can also do the same thing. Okay. So let me write the problem for you here. It's an interesting problem. It's 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3. And if you want, let me add one more to it. 1 over 1. It's better. And then plus 1 over 1 plus 2 plus 3 plus 4. And then you continue up to 1 over up to 99. So it is pattern inside another pattern, yes? Because you have two dots. One appears between the terms. But by the way, if you can succeed to solve it using GeoGebra, that's also a very good step. But after doing that, you can come back and try to see, can you yourself, without calculator, being able to calculate this interesting sum. Okay? Okay. Now let us finally reach to the last point, and that is about division. Division of integers, I will not talk about them. I hope that you know about it. But for example, in high school, we usually don't have this symbol. It's not wrong, but usually instead of that, we write its equivalent in the form of a fraction, a over b. So these are exactly the same things. Okay? But let me ask you one question. This question is extremely important to know. It's fundamental, and I'm sure that you know that. If I want to divide this fraction by another fraction, for example, 5 over 7, how can I calculate this? Do you remember what is the rule? Yes?
You can flip the other fraction and take the multiplications.
Yes, exactly. So that was the rule that you know. So it is 2 over 3, and then you change this division to multiplication, but the price that you pay is to flip. Yes? So it means division problem is not a new problem. You just turn it into multiplication, and you already know how to solve the problem. Yes, and then if you want to solve that, pardon? So then, first of all, it's important to simplify if possible before continuing. In this case, I cannot simplify them. Do you remember this kind of simplification for multiplication is allowed, which is not possible in this case. This kind of simplification is also allowed. So let me just draw some chart here for you. So this kind of simplification is possible. This kind of simplification is possible. This kind of simplification is possible. This is possible. This is also possible. But in this case, unfortunately, none of them work. Then I don't have any choice. I have to multiply the numerators, 14. I have to multiply the denominators, 15. Yes? So as simple as that. But let me also ask you, what do you think about this problem? For example, I have 1 2/3. I want to divide it by 2 3/5. If I want to divide these two mixed fractions, the standard way is to do what?
Convert them into
Proper fractions and do the problem and solve the problem as before. By the way, this is the phrase mathematicians use a lot. We change this to that and then we solve the problem as before. So it means that we are reducing a new problem to a problem that we already know how to solve. Okay, so what I do, I just write it. Do you remember what was the trick? 3 plus 2 is 5/3. Don't be in hurry. 13 over 5. And then I would write 5/3 multiplied by 5/13. No simplification in this manner is possible. So this is 25 and that is 39. Yes? So that is something we have. But sometimes, I told you that people write it in this form, you know. If I have A over B divided by C over D, sometimes you see this in the books. Sometimes you see in your book, they are using this symbol. That is also possible. And my preference is to draw it horizontally like another fraction. It's not a new type of fraction line. So I really don't need to do that. So I would write it like this. So whenever you see this, I am dividing two fractions. Whenever you see this, I am doing the same thing. But of course, if I ask you to calculate this, if I ask you to calculate 2/3 divided by 5/7, you don't need to remember what I am going to tell you because you can change it to the form of 2/3 divided by 5/7 and then you can write 2/3 and then turn it to multiplication 7/5. And simplification is not possible, so you have this and the end of the story. But whenever I see this, I do this trick. I multiply the ones that are far away from each other, is 14. I put it in the numerator. I multiply the ones which are close together and I put them in the denominator. So it is faster. Okay? So I want you to learn this trick. That's not mandatory. You saw that I didn't even use it. I was able to calculate it. But when I wanted to use it, I can do it faster. And by the way, the first thing that you need to be careful is to learn precisely, but after that, I really recommend you to try to do it fast. Because when you do it fast, it is a very good train for your brain to concentrate. It really helps you, because if you are doing something very fast, you cannot be distracted, otherwise you will not be able to do it fast. So it's a very good train. Okay, so here, this is clear. But now we have some kind of compound fractions, for example, like this. Let me do the very, very simple example here. So I want to calculate this. I'm sure that you know how to do it normally. What should I do? This is a fraction. In the numerator, I have the sum of two fractions, and the denominator, I have the difference of two fractions. So how many operations are involved here? Addition, subtraction, and division. But we know the priority is here with these two. Why is that? Because we usually tell that the priority is with division. Yes?
Because you can't really do it, so you need to use brackets.
Brackets. So this, if you want to write, if I ask you to write this expression horizontally, if you write like this, this is wrong. And then if you ask the calculator, calculate this, this is the wrong way. This is not the translation of that. Okay, let me ask you. If I ask you to calculate this, how many operations you are facing?
3.
Again, 3. But the priority is with which one?
Division.
The division. Okay? But this is this one. Okay? So be careful about that. So this is actually, or what convention or whatever, this means this. Okay? So you want to divide this number as a whole divided by this number as a whole. You are not dividing this by this by that. That's wrong. That's not the correct interpretation. But I'm sure that you know what to do that. That is simple. So what you do, you first focus here, assuming that nothing is down there. If you want to solve that one, you need to find the common denominator in the lowest term, which is 6. And now can you tell me what should I write here? What should I write here? 6 divided by 2 3 times. 3 times 1 is 3. And then I have addition. 6 to 3 2 times. 2 times 1 is 2. And I will do the same trick here. So the common denominator is again 6. 3 times minus 2 times. And I continue. 3 plus 2 is 5 over 6. And then 1 over 6. So then I told you that you need to multiply these two, multiply these two. But you can simplify as well. Okay, let me just do it, not to confuse you a lot. So what you do, you multiply 5 by 6, write it in the numerator, and 6 by 1. Now you understand that 6 is gone. This is why I know that this will happen, so I see ahead of myself, and I simplify it here rather than do it here. Okay, anyway, the answer is 5 over 1, which is 5. So the answer to this is 5. But this is not the way that I do it. I can do it a little bit, probably 2 seconds, 1 second, by this method that I am going to tell you. If you want to calculate these compound fractions, I would recommend you to rescale the fraction in a way that you get rid of all fractions. For example, I multiply everything by 6 in my head. Okay? So you know that, for example, if I have a over b, you know that if I multiply a by 6 and I do the same thing with the denominator, this fraction is equal to the fraction that I had before. So if I multiply this by 6 and do the same thing here, I am not changing the problem. So that's good. I don't want to change the problem. I have to solve the problem the teacher asked me to do. Okay, so I multiply everything by 6. What's the answer? If you multiply 6 by here,
6 divided by 12.
It is 3, yes? Yeah. Plus, if you multiply 6 here, 2. If you multiply 6 here, 3. Minus, if you multiply 6 here, 2. What is 3 plus 2? 5. What is 3 minus 2? 1. So the answer is 5. Okay, and that's the answer. It's a faster way of doing it. And if you want to appreciate the difference between these methods, so let me give you a little bit non-trivial example. That was very simple. But for example, let me ask you to calculate this. I'm not saying this is easy. You need to spend a little bit of time. But let us see which method is better. Of course, if you are good with numbers, this is going to work. Okay, so what do you think? I don't know how much you are quick with numbers, but if you are not, you have to a little bit suffer here because you have to calculate this and now calculate this. But can you see a number so that when I rescale it, all these fractions are gone?
48.
48 will take care of this one and that one and that one. You are right. But it will not take care of these 3.
36.
36 will take care of this one, but not 24 and this one.
80.
No, so it's a random guess, yes?
2.
2? No. You want to multiply so that the denominators are gone. No, we need least common multiple.
480.
480 will work, but this is probably too big.
240.
But do you remember what was the trick? I want to remember. No one told me about my trick that I told you. I told you how to find this systematically. Factorize. Okay, let us do factorize and do the factorization in our head. Okay? So, anyway, can you factorize it in your head? Yes, because this is 4 times 3. But what is 4? 2 to power 2, 3. Yes? This is factorization. Of course, if you don't like, you can just write this vertical line.
Yeah.
But be fast. 18 in your head.
2 to 18.
2 times 9, but 9 is 3 to the 2.
2, 3, 3.
So 2, 3, 3, or 3 to the power of 2. And then 24 in your head.
2 to the power of 2 times 2 to the power of 3.
No. Yes?
2, 3 times 3 times 6.
3. 8 times 3. Yes? And then what else? 36 in your head.
2 to the power 2 times 3 to the power 2.
Exactly. Because 4 times 9, yes?
What the fuck is
And then 48.
2 to the power 4 times 3.
Yes, exactly. So you see, if you pay attention, you become better and better.
because he just needed that.
Okay? Now, can you tell me how many numbers are involved? 1, 2, 3, 4, 5. So let me see how many of you remember. I want to find the LCM of 12 up to 48. So do you remember what was the trick? I need to look at all common factors. Of course, we are lucky. All of them are either 2 or 3. So I have to put a 2 and a 3, nothing more. But do you remember what was the rule for the exponent?
The highest.
The highest one. The highest one for 2 is how much? 4. The highest one for 3 is? 2. So that was your number, which is 16 times 9, 144. Yes? So this is the number. This is your magic number. Okay? So now let us calculate this. I want you to calculate it in your head again. I multiply everything by 144. Tell me what will happen for the first one.
It's negative 1 over.
No, not negative, this one. So let me tell you, 144 in my head, I want to multiply it by this.
Oh, okay. You have
But what is this one and then this one? If you divide them, divide this here. 144 is this one, 12 is this one. So if you divide this by this, what will happen? 2 2's remain, 1 3 remains. 2 2 and 1 3. What is that? 12. So this, the first number is 12. Let me see how many of you understood it. Negative sign. Okay, tell me, 144, 1 over 18. What's the answer?
it's 2.
It is 2 to 4, 3 to 2 divided by 18. 18 is this one. It's how much? 8, exactly. 2 to power 3. Yes? And then minus. What is 24? 24 is 2 to power 3, 3. What is left?
2 times 3
6. Yes? Okay. And now, what is this one against? Oh, okay. Can you tell me what will happen here?
Oh shit.
Yes, so you multiply 5 over 24. We learned what happens here. It was 6.
Yes.
But 6 times 5 is 30. And then what happens here?
Yes.
Now you calculate. 36 is 2, 2, 3, 2.
4. We have divided them.
What's that?
It's 2 to the power
4.
4.
7,
20.
28.
Yes.
And then here,
48.
it's 3 times. Yes?
Yes.
And then plus, so minus plus 3. Yes? And now you start adding them up. So what's that? 4. You see, I reduced this complicated problem to a simpler problem because 12 minus 8 is very simple. 4 minus 6 is minus 2. And then this is 2 plus 3, 5. So the answer is minus 2 over 5. Okay? Something that I want you to show in Geogebra as well, it's also good to know the way that you type it here in Geogebra. So if I want to put the same numbers here, you see, you have to predict what is going to happen. Look at here, the way that I type, 1 over 12, apparently correct, minus 1 over 18, apparently correct, and then minus 1 over, what? 24. Then I want to go where? Down. But see what will happen if I put division. Division will only affect The last one. As I told you before, they are not equivalent. Do you remember? So if you want to type something like this in GeoGebra, you have to foresee what is going to happen. So you need to know that you have this. Oops. So it means that I messed up. So let me type it from the beginning, okay? So this means that I have to open a pair of brackets in the beginning. I have to foresee myself. And then I start typing 1 over 12. And then go here, minus 1 over 18. And then go here, minus 1 over 24. And now, when I go out and put the division, it automatically removes the pair of brackets that I didn't need. Okay, and then I can simply type in the denominator. What is that? 5 over 24, and then I go minus 7 over what? Over 36, and then I go to the last one, minus, and then this is a little bit strange, minus, it doesn't work with, yeah, it works, and then divided by, let us see if the GeoGebra is capable of doing this in this way or not. Minus, it's minus 2 over 5, and that's correct. So I mean, sometimes you have to anticipate in advance how to type. Yes, that is something that you have to learn. Okay, any questions? Yes.
I think, can I see if my answer is right on the other?
I will come to you. I just want to tell you that I will stop here. The lesson for today is finished, but you need to continue because we have 35 minutes. I ask you, please go back to Google Classroom. You are completely okay. That is up to you. Do not ask me to decide for you. If you think the problems in the book are simple, don't waste your time just by chatting or whatever. You can take that hard problem and to think about that. That one I wrote here. Or keep working as you prefer for your life. That is your life, not mine. So I cannot decide for you. Okay? But don't waste the time. You can 5 minutes go around, just go to the bathroom or whatever and come back here. You have 30 minutes, which is valuable. Don't waste it. And go to Google Classroom. The people who are not interested in harder problems, the one that I have written on Google Classroom is the minimum necessary that you need. No, we don't end. If you are tired, you can still rest for 2 or 3 minutes and come back. I will check the attendance after that.